think this is how a good or how your load analysis table is supposed to look like. For this example, for this my own, you can see these are all my appliances. And please take note that these are the ones that our client or your client wants to run them on solar. Any other appliances that is not included here, it means it's not going to run on solar. So make sure that it is only those that you intend to connect them to your solar that is listed here. Any appliances that is not here is not going to be connected. So even after your load analysis and when during your installation, if you have not added any appliances here, do not connect it to your solar. Make sure that you always remember that. And the next column is the quantity, the number of our appliances. The next column is their wattage, that's their power consumption, which is in watts. So this is where we are going to list them. And the next one is the total wattage of our appliances. The next one is their running hours or run hours, anyone, how many hours the clients want to use each of these appliances in a day. And the last column is their energy consumption. For each of these appliances, this is their energy consumption in the last column. Let me erase this. So you can see our television. Just for a recap, our televisions, we have two televisions. Each of these television consume 100 watts. Then the total watt of these two television will be 2 times 100, which is 200 watts. And they are running for 5 hours, which will multiply this and this. So we multiply this 200 watts by 5 hours, it will give us 1000 watt hour. For our fans, we have 4 fans and their wattage is 75 watts per item. That's per each fan is consuming 75 watts. When you multiply 4 times the wattage, which is 75, it will give us 300 watts. And they are running for 8 hours. When you multiply 300 times 8 hours, it will give us 2400 watt hour. You do the same thing for this LED bulb, 10 pieces. They are running for their wattage is 12 watts, and their total wattage should be 10 times 12, which is 120 watts. And they are running for 8 hours. They are running for 8 hours. Their total energy, that should be 120 times 8 hours. That's 960 watt hour. Now there's something I want to draw your attention to. When you're conducting your load analysis, sometimes you feel like some of these appliances are too small, so you will not include them during your load analysis. And then you just went ahead and design your system and you install it. After you install it, you discover that the battery is draining faster. You now begin to wonder what is draining this battery. The problem is maybe you overlook these bulbs because you think these LED bulbs, because you think they are just 12 watts. You overlook them. But when they gather together for 8 hours, running for 8 hours, they consume almost 1 kilowatt hour. See, they consume 960 watt hour. So that's why when they tell you and when they said solar is calculation, this is the critical part of the calculation. Sometimes you overlook or you think this appliances is too small, so you don't include it. You think when you size your system, it will power it up, and then it is those that you refuse to include, they are the one that will start stressing you. Things like this LED bulb, things like this Wi-Fi. For instance, for this Wi-Fi is just one and is It's just 15 watts running for 24 hours. It consumes almost 360 watt hour in a day. You can see laptop, all the small one, phone, 4 phones. The phone is 18 watts. You see it's consuming 216 watts. So all these small appliances, when you gather them together, they consume a lot of energy. You can see this one. Let's assume you do not include this one. You do not include this laptop, these laptops. You do not include these phones because you think they are small. Now when you multiply this, so when you sum this one, let me clear this drawing. Let's assume you didn't include this LED bulb because you think they are small, and this Wi-Fi because you think it's just 15 watts, and these laptops because you think it's just 65 watts, so it's not much, and the phones you think the phone is just small. Now if you not include this one, and if you multiply if you sum all of their energy consumption, this one, and this one, and this one, you see that they are consuming more than 2 kilowatts of energy, which is very bad if you do not include them because you are thinking they are too small. So all I'm trying to say is, no matter how small those appliances are, always include them. If you are not going to include those appliances, then make sure you oversize after everything. Make sure you oversize the energy, the daily energy. Make sure you add some extra margin in order to cover for all these appliances that you did not mention. So always take note of that. And like I said earlier, anything that is not here should never be connected to your solar system. Anything that did not include here should never be connected. If your client say okay, he wants to add additional AC after you calculated or you use 2 AC, then the client say you want to add additional AC, then you should come back here and add that additional AC before you go and carry out your installation. So make sure you take note of all this. Now, after you have done with all your calculations and all your figures are right, the next stage is to sum all of this column to your total wattage. You sum everything together, as well as your daily energy. You sum everything together. You sum all of them together. So for this total wattage, which is 3,507 watts, that's our total wattage. It is this one that you use when you are sizing your inverter. You use this one to size your inverter. And for your daily energy consumption, which is 23,276, you use this for sizing your solar panels and your battery bank. So always take note of that. Your total wattage is when you sum all your total wattage, you use that figure for your inverter, and this one you use it for your battery bank, that's your daily energy, and your solar panels. So for this one, how to size inverter for this load, I'm going to do a video on that, so make sure you are following. I also do a video on how you can size solar panel and battery bank for this particular load analysis, for this particular figure. So make sure you are following. Thank you for watching, and make sure you subscribe to this channel for more videos like this. If you have any question, if you have any suggestion, please make sure you drop them in the comment section. Thank you very much and remain blessed.